Hi, everyone. Good to see you again remotely in our respective bubbles here. Hope everybody's doing well. We're sad that we couldn't meet up again this year in person. It's always something I really look forward to. But I hope you're all doing well and excited to chat through this with you this year as well. So I'm just going to share my screen because that's definitely more interesting than just hearing me talk without a presentation. So I think the first quick thing we might want to do is just make sure everyone's on the same page about the nature of the problem we're looking at. It's essentially a problem around connectivity. And how do you enable connectivity while meeting the extremely high standards of security and tamper-proofness that smart contracts provide? Now, I'm not sure if everybody's familiar with the Oracle problem, but basically the blockchains that we all rely on and all like very much for their security properties and their tamper-proofness properties have inherent limitations while creating those properties. One of those inherent limitations is limitations around I/O and limitations around how we connect to external data sources and whether the miner set that creates the blocks and secures transactions is the same miner set that should be responsible for putting in data. And so that's an assumption that's very dangerous to play around with, and the majority of pretty much all the real blockchains have basically said, no, we're going to have a miner set that focuses on packaging transactions into blocks and securing those transactions within a certain scope of transaction types and within a certain scope of kind of smart contract VM capabilities. And we're going to do that kind of infinitely into the future, right? And so it is this focus on generating these blocks and securing them at the highest possible level of security that leads to this limitation of not being able to access external data sources. Now that might sound like a relatively small limitation, but its implications are quite large. One of the fundamental implications is what we see in our industry today. So right now there's a lot of tokenization, basically because tokenization generates all the data it needs inherently within the system on its own. So for the creation of tokens and for the voting around tokens using private keys, you don't need any system. You don't need data from outside the system. So all the data is generated by the token contract. And this is actually, in my opinion, why there are so many contracts around tokens and token ownership and voting in relation to tokens. It's because that's inherently the functionality you have when you spin up a blockchain or you begin using a public blockchain. And that's because it doesn't need access to external data. But as the access to external data increases, you already are now seeing through DeFi a shift, right? So you're seeing people going from let's make tokens because that's what we can make out of the box to let's make more advanced smart contracts. And the universe of advanced smart contracts grows linearly with the data available. And then eventually when there's enough data that you can combine it in interesting ways on chain, it stops growing linearly and it kind of expands much greater from there. So you basically arrive at a world where you're going to see a shift from just tokens and voting to all these more advanced smart contracts on the basis of access to data. I've already seen a number of these shifts. The first one was with something called Bitcoin multi-signature. That's all you could do when I started. You could sign off for multiple signers, move Bitcoin. Very advanced for its time, still very cool, but that's kind of where a lot of things started. Then you went to protocol smart contracts that had you put a smart contract into the actual protocol's code, that would take months to sometimes over a year. Ethereum then came along and deserves a lot of credit for giving us scriptable smart contracts where people could take the time from generating a contract down from years to, well, not years, months to over a year, down to a few days or a week. And so that functionality, that ability to generate smart contracts, even if it is around token generation, token transfer, and voting, created this token explosion, right? This ICO kind of boom. And that is what came to redefine our industry a few years ago. Now I think we're in a stage where you're having scriptable smart contracts that people are trying to write about more advanced use cases. They're writing them about DeFi, about decentralized insurance, around VPN systems, around a whole bunch of different various systems and use cases. And I think this shift is really being driven by connectivity to external systems, right? So what you're basically seeing in DeFi is a massive growth based on a new functionality becoming available, right? So you saw a boom in tokens once the functionality of token generation became available. And now you're seeing a boom in more advanced smart contracts because the second half of these contracts has now become available, right? Most developer teams that actually use the research you guys will create and use the systems that you invent will not be super well staffed, abundant amount of engineering resources teams. There will be 3 to 5 person teams initially that need to efficiently and securely generate some kind of smart contract offering. They need to give a value proposition to the user, and they need to maintain their security. And my opinion, our goal as industry participants, and partly your goal in the academic sphere, is to create advances that allow these teams to build these applications in both a secure and efficient way, right? So I think what we're really going to be discussing is, now that we're seeing this second part of smart contracts become useful, what are the nuances around how to secure it properly, how to assure its proper operation for the smart contract, how to prove that proper operation to the users of the smart contract the same way they can rely on blockchains and all those types of things. So I think the thing to really keep in mind is what is the nature of the problem. So the nature of the problem is, I have all these blockchains, I have all these inputs, I have all these outputs. The blockchains can't access data sources. They can't even access crypto price data, which is the most popular data category right now that we're serving and that other people are serving to DeFi contracts, and APIs, just all APIs in general. So basically what you're seeing is, I need contract inputs. Those contract inputs are going to get more in demand. They're going to get more advanced. Then you're going to see some amount of contract outputs as well, as the more advanced version of these DeFi applications need to affect changes on other chains or in other payment systems. And you're going to want this to happen across blockchains. So you don't want to build some kind of basically blockchain middleware or blockchain abstraction layer that sits and works on a single blockchain for a single use case. That's going to be a relatively fragile, inflexible system that isn't going to properly address both the evolving needs of DeFi and the needs of the many other use cases out there. So in my opinion, the goal of the academic community and of the industry side of things is to generate a general purpose abstraction layer between blockchains and all these inputs and outputs. The first category of problems here is relatively straightforward for people now. It wasn't straightforward before. It became straightforward once people started putting value onto these applications. So before people put value, 2 years ago, people would say things like, yeah, I'll have an Oracle, I'll run my own Oracle, it'll be fine, it'll be okay. Now, based on a few Oracle failures and some other obvious security concerns, this is no longer okay, right? So the lesson from this for industry participants and academic researchers and people working on this type of body of work is really that additional value within smart contracts begins to change people's requirements for how their secure systems function, right? So even if secure systems can function in a certain manner at the proof of concept or MVP or hardly usable, first version, $10,000 secured thing, those requirements change. And they change very rapidly as value is put into these contracts because the fundamental security guarantees need to be there. And this is what we saw with centralized oracles being okay. And now those services are not really used by any DeFi teams. The people that have centralized oracles that they run are trying to get away from them as soon as possible. There's all kinds of issues with those, which we'll go into some of those, and others we won't unfortunately have time to cover. So fundamentally, the logical next leap would be, how do I create a decentralized computation method and environment that can apply the same decentralized computation assumptions that secure the blocks and the transactions to this data validation, right? How do I properly transfer data from less secure off-chain systems into these more secure, more tamper-proof on-chain systems while maintaining two key properties, both the security and the kind of almost the validity of the data that's triggering the contract, as well as ease of use. So essentially flexibility and the ability to actually apply what was built to create a smart contract. And what we actually see is that in different stages of the process, there are some key considerations. So now I think we'll really start to discuss what the problem space is and what are the different categories of problems that need to be reasoned about. Obviously, there are more categories of problems than these, but these are just some key considerations. So one key consideration is what is my data quality? What is my data source? Can my data source be manipulated? If I use a single exchange API for a thinly traded market, and that thinly traded market then gets manipulated, I architected a faulty product that doesn't even require people to know how to code. It just requires enough money to manipulate the data source, right? So there are fundamental issues around how do I define data quality? How do I assess the proper interaction between data sources and my immutable, irreversible, extremely difficult to refund and fix smart contract, right? Because the trigger now owns that contract. It controls it. The next stage of key considerations would be proofs of what came from a certain origin. That's proving that data did indeed come from a certain specific TLS session or server or API. You have data delivery and validation. That's the job of the Oracle network, is to both provide a reliable blockchain abstraction layer that delivers the data, but also to serve in validating the reality outside of a blockchain to a sufficiently high degree that it can trigger a smart contract. So it's not just about, I want to transport data. In many cases, it's about, I want to prove that the external world to the blockchain is in a certain state. And proving that state requires not just data delivery, but validation, often from multiple sources, if you can get them. The next key consideration is often cryptoeconomic guarantees. So once I have the data transport layer and I can validate the data, how am I guaranteeing its delivery? What are the incentives and the various other technical guarantees I can provide to make sure the data is delivered to the contract? Because the contract is wholly reliant on the data to arrive, or else it doesn't function, becomes open to manipulation, theft, various other adversaries doing things to it. And then the final consideration, which unfortunately we won't have enough time to go into, would be data privacy. You want to avoid certain front-running scenarios. You want to avoid certain data privacy considerations of contract creators, and data privacy is a later stage problem that oracles are going to be solving. In many cases we are solving, but the space hasn't gotten to the point where it needs data privacy just yet. Right now people are just making some kind of fundamental financial products around lending and derivatives where privacy isn't a key consideration yet, but it definitely will be. The way that we think people should approach this is to examine blockchains, to examine oracles and blockchains very separately. So we don't think that you should look at an oracle mechanism as if it's a blockchain that delivers data. That doesn't make sense. The fundamental problem here is different. It is about delivering data, not generating blocks. It is about assuring the data was delivered correctly, not about securing a transaction in an immutable ledger that can't be manipulated by an adversary. So just two completely different sets of problems. And a lot of times what people do is they say, oh, let me take a blockchain, let me fork it, let me kind of take the blockchain assumptions I have and just sprinkle some oracle ideas in there and it'll be fine and I'll have a wonderful oracle. That doesn't work. So I think at the core of research and thinking about these problems, there needs to be a deeper understanding about what is the fundamental outcome from such a system and what are the guarantees that it needs to provide when compared to the guarantees provided by a blockchain, right? So the fundamental guarantees it needs to provide is data delivery. It needs to provide guarantees that data came from a source, was validated in a specific way that's provable, and then guaranteeing that the data will be delivered to the contract at the level of quality, in the frequency, and over the time period. The way that many people approach this is they don't think about this and they just connect to random APIs. So what they basically do is they connect to some open API, they don't do credential management, they don't provide any guarantees from their oracle to the contract, guaranteeing that the data will be delivered. And they basically say, it's fine, the data is going into a blockchain. If anything that goes into a blockchain is secure, nothing to worry, nothing to see here. Once again, you as researchers and people that look at both blockchain systems and those of you who are interested in looking at oracle systems, I would not view oracle systems in this lens. I would refocus on the inherent actual problems that oracles seek to solve, which are the problems we solve, which we're very excited to work with you on and thrilled to discuss, more during this conference and also via email. Well, the way that we approach this is we, from the beginning, have had credential management within our nodes. We have made sure that we access premium data sources that we can properly score and evaluate for quality. We look at guaranteeing the proof, a certain TLS proof or various other trusted hardware-based proofs to show that data did come from a specific source. So you have a focus on high quality data, right? Because you don't want a garbage in, garbage out dynamic. Then you need to focus on guaranteeing that the data is delivered to the abstraction layer. Then you want the abstraction layer to validate the data in certain kind of steps that the user basically agrees are the right steps to validate the data to the sufficiently high degree that them and their end users value. And then here you see something called an on-chain service agreement, where you're looking at a way for a guarantee to appear that the data will actually be delivered. So this highlights, I think, the difference between how some people build oracles and the lessons that we've kind of hard-won lessons over many, many years now. We've been building smart contracts for 7 years, oracles for many of those years. And I think the fundamental error that people make is they either think about oracles as web services, and it's as simple as a web service, or they think about oracles as a blockchain. It's as simple as calling it an oracle a blockchain and generating blocks. And it's just an entirely different set of problems focused on both data delivery and data validation to guarantee an outcome for a contract. And this is how we've architected our system, and these are the types of problems that I think are worth going into. Fundamentally, from our point of view, how this architecture looks is you have a variance where data providers run their own nodes, and then you can enforce data quality incentives for a node operator that is a data provider. And then there are node operators that don't run data sources, right? So you have data sources that are forwarded from basically relayers, node operators that put that data into a reference contract used by these various blockchains. What this does is it gives you two things. The first thing it gives you is it allows you to take the data providers that have the better data and want to get paid a premium. They can run a node and they can provide the data on chain. And then you have a flexibility to allow data sources that can't run a node to also provide the data on chain. So that's another important consideration, is having a blockchain abstraction layer that's flexible enough to include various data sources and to actually include them in greater and greater degrees of security guarantees to the user. So you should be able to include a data source with that data source having to do nothing short of operating their existing infrastructure. And you should be able to include a data source that wants to be as integrated as humanly possible, and you should allow it to provide as many guarantees as possible. So this highlights, I think, a property of flexibility. You do need an abstraction layer that doesn't just work for a single use case, both because that use case will evolve and because there are many, many other use cases beyond basic financial products on chain, right? Those use cases are going to be appearing. I know they're appearing because they're using our system, and I know all of that's kind of happening. And if we're talking about DeFi and lending and derivatives today, we're going to be talking about decentralized insurance tomorrow. And you want this same set of assumptions to hold for that group of smart contract creators. What all of this really leads to eventually is a web of trust model, where the usage of somebody as a data provider or the usage of somebody as a node operator provides a lot of insight about their reliability over time and the types of guarantees that they've historically given people. So over time, as a single Oracle network or a single Oracle mechanism gains more and more usage, or even a single node within an Oracle network gains more usage, you essentially ascribe a trust through usage, the same way that the web of trust PGP kind of schema attributes trust through signing. So eventually what you'll see is, or you're already seeing now, is the ability to attribute greater and greater node operator quality, data source quality, reliability guarantees, various other guarantees to specific nodes based on their usage. And this will drive those nodes to get more fees. Because at the end of the day, what people pay for in our space, in theory, and sometimes in practice, is security. And you need a system that will allow the more secure operators, the better data sources, to rise above the rest and get a superior portion of the fees. So in addition to guaranteeing that there is data delivery and making sure that there are high quality data sources, you need to create the right incentives for both the node operators that are just forwarding data and for the data sources that are providing that data, with them eventually becoming node operators, as many of our data sources already have. This kind of brings us to our next set of assumptions and our next set of questions around how do we create these incentives. I think here there's another sort of, not exactly counterintuitive, but important idea about the differences between blockchains and oracles and how to reason about an oracle mechanism security, once again with a focus on data delivery. So if you look at something like Bitcoin, I personally think you see what I call implicit staking. You see people holding Bitcoin or holding miners that are essentially future Bitcoin and not wanting to deviate from the protocol because they hold either straight Bitcoin or an asset that is future Bitcoin. And this implicit staking basically aligns them to maintain their proper participation in the protocol because they don't want the value of those underlying assets to be reduced. And it's this very important relationship between their holding of assets and their proper participation in the protocol, which I think hasn't been formally stated enough, but in my understanding, I call it implicit staking, right? And now you see this application of implicit staking to proof of stake chains, right? And basically, instead of mining equipment, you now have token ownership as the asset that people don't want to decrease in value, which makes sense, right? You have an asset, you don't want it to decrease in value. You're going to participate in the generation of blocks properly. If you deviate from the proper participation in the generation of blocks, the value you have could go down significantly. So you don't deviate, right? Now, the issue that I see, and for people doing research, this is just another pattern to avoid, is I see people basically saying, I'm going to make a blockchain, I'm going to use the staking proof of stake mechanism, and that's going to be related to data delivery. And it isn't related to data delivery. The generation of blocks through even some kind of staking mechanism doesn't guarantee high quality data delivery, doesn't enforce high quality data delivery. It simply generates more blocks. And that's fine if you want to generate blocks, right? If you want to fork a blockchain, generate blocks, and that's your goal, then that's fine. But I think what I'm trying to highlight is that when researchers think about this problem space, I would really first start at what is the fundamental issue we're solving. And it is being solved with decentralized computation, but it is being solved for a different set of problems, right? Decentralized computation applied to a different set of problems. For example, in our system, you have something called explicit staking. So you have implicit staking where node operators do hold link, and great, they hold it and they don't want it to go down in value and they don't deviate from the protocol the same way Bitcoin miners don't, and the same way that proof of stake chain miners don't. But through that service agreement dynamic that I showed you before, they can actually lock link against specific outcomes, right? So they can say, if data isn't delivered correctly, I need to pay out stake to the contract holder, right? Or burn it or some combination of both. But it's connected to data delivery. So I think the largest insight that I can provide from what we've been building so far, what we've seen in the market and how we've seen other people approach the research around oracles is I would look at those key considerations. I would think about how do they fit into a properly functioning oracle mechanism from the point of view of data delivery, from the point of view of data validation, and from the point of view that you create incentives to properly give the data to the contract against the conditions that it needs to meet, not some conditions that, you know, some blockchain came up with, but the conditions of a specific contract. And in these dynamics, systems like Town Crier, Deco are very useful for connecting all of the proof back to the contract. And the service agreement is very useful for connecting a guarantee between the smart contract and the actual oracle. And it's really this set of problems that we work on. It's this set of problems that we've turned into a functioning system that, as Patrick said, feeds the vast majority of, well, by number of DeFi applications, we are the most widely used oracle mechanism now. We secure a large amount of the value in the DeFi space because we focused on solving data delivery problems, not block generation problems, not transaction securing problems, but the actual issue that an oracle is meant to solve. The system that functions correctly in this dynamic also needs to grow in its security as usage grows. So you need fees to flow into a system that directs those fees to better and better data sources, better and better node operators, better and better composition of ensembles of node operators to make sure that the data quality and the security of data delivery scales with the value secured. And it's really the dynamic around not only how do you create a good data delivery mechanism, but also how do you validate the data, how do you guarantee that the data is going to be delivered, and then how does the security of that oracle mechanism scale properly over time with an increase in the value it secures? And also, how does it flexibly adapt to the different smart contracts that want a different manner in which they interact with the data, right? Because the interaction from an insurance contract and from a DeFi contract might be extremely different. Likewise, for many other contracts, even now we have, service level agreements for VPNs. We can prove that a certain VPN is operating correctly, and that's guaranteed by contracts and validated by oracles, right? So you have a huge variability. So you need to make sure you have high quality sources. You need to guarantee data delivery into the mechanism. You need to prove it came from a source. You need to validate that data. You need to get that data into a contract with a high level of guarantees that it's actually going to get into a contract. And you need that to scale in security, data quality, and all these other assumptions as the amount of usage grows. If these are issues that you're interested in, we're thrilled to work with you on this. We work with many people from our IC3, including Ari Jules and many other great folks in the IC3 community. We'd be thrilled to work with you as well. If it's something you're doing research on, if it's something you're thinking through, we'd be thrilled to have a dialogue about this, hear the research you're doing, hear any ideas you have, any ways we could improve the system, any issues with the system you think we should work on. We're very, very open to that, and we'd be thrilled to talk with you and already work very closely with the academic community. So thank you.
Thank you for that, Sergey. We don't really have that much time for questions remaining. I can just ask one quickly. You mentioned inside the system, there's going to be this staking aspect where, I lock up link, and then if I don't deliver, I might end up giving it to the end user. I just wanted to ask, is that more to do with if I don't send the data at by a certain deadline, or is it to do with the quality of the data?
It has to do with everything. So it has to do with all of those parameters. So this is, I think, the very important nuanced point here, Patrick, is that in the real financial world, you have extremely clear definitions of the data that's going to be triggering financial products. And that definition is very important because it determines how the product is going to function correctly or incorrectly. And there's a lot of dials there. So there's a lot of levers and dials. There's a lot of nuances around how to actually trigger a contract. That varies between contract types, even within the financial kind of products category. And so what you need is you need it to parameterize all of that. You need to basically say, this Oracle network composed of 15 or 25 oracles or 50 oracles is going to deliver to me over the life of this financial product at this frequency, at this quality, with these proofs of data origin, and with this level of Oracle network validation. And those are the extreme requirements that contract needs, because if those requirements aren't clear, I already see it very often. People will want to know the end-to-end security assumptions of their contract. And when they can't dig into what's controlling the contract, such as the Oracle, they will start to sit there and think, why am I putting $1 billion into this? Why am I putting $10 billion into this? Why am I putting $100 billion into this category of smart contracts, right? From a specific developer. And I think that you need, just like you have clarity about how the blockchain is going to behave a certain way, you need an extreme level of clarity about the way that an Oracle mechanism is going to behave. And that requirement will increase over time as the value secured by these contracts increases. So you need not only a system that can do that at like a foundational level, how it's architected, but you also need people to be able to come and say, oh, whoa, I have another 200 million in my contract. I now need this greater guarantee. And then they should be willing to pay a greater amount in fees, or I know they already are willing to pay a greater amount in fees. And those greater fees will lead the node operators to provide better data at higher frequency, maybe run some trusted execution environments, run some more costly zero knowledge proofs from something like Deco to show that data is being delivered properly. And it's these types of dynamics that really need to happen for the security of an oracle to scale with the security of the value secured by the smart contract itself. Does that answer the question for you?
No, it does, yeah. I like the point about they're basically willing to pay whatever they want. I remember for the Black Thursday, for the Keeper auctions, the MakerDAO paid 4,500 Gwei to try to get a transaction in, because what they were trying to secure was way more than 4,500 Gwei. Yeah, thank you for that anyway, Sergey. We don't have time for any more questions. So again, thank you for your presentation. I think everyone really enjoyed it.
Yeah, I hope it was helpful. Hope we were able to clarify some points where people go down certain rabbit holes, and very excited to chat through all this and work on this together. Thank you very much.